Hey everyone, thank you all for joining the webinar. My name is Shweta Singh. I lead the product management team here. I started at Spatial about 10 years ago, straight out of college. I was part of the 3D InterOp development team. Worked there for 3 years, moved on to the business side of things. And today I wanna discuss this new product that we've launched with you. This product is very close to my heart, given where I started. And let's get into it. So to start, in order to discuss why we decided to launch Data Prep, I wanted to talk a little bit about the evolution of CAD interoperability and how Spatial has always been at the forefront of anticipating industry needs around CAD exchange and delivering a solution that fits it. So for example, in the 90s, the industry really needed a way to exchange CAD design, and we were the first to offer CAD interoperability tools with 3D Interop. In the 2000s, DMU was really taking off, so we started offering native CAD support. In 2010s, we started offering PMI support as model-based design, became popular. And then looking at now, we think our customers really need a way to handle large models. So not just import large models, but be able to offer a way to interact with them in a way that is still usable for the users. And looking forward with the converging megatrends of AI, sustainability, a shift to the web, we can imagine needing tools to train AI models with the right CAD files, simulate things relatively quickly, to simplify models such that they can be streamed to the web better. And that's why we're launching Data Prep, because we think it's really, now is the time to be thinking about these problems and solving them. So what is Data Prep? Data Prep, it's a new add-on to 3D Interop. What we're doing is we're basically leveraging 3D modelers like ACES, CGM under the covers to perform a lot of the CAD preparation that we know our customers do anyway after doing the import. So this preparation will occur during the import itself. And what will happen is the embedding applications, they'll be able to generate what I call model derivatives during import itself. Thus, they can handle large models downstream in a more efficient manner. How does it work? We wanted to make it very simple. So it's just through options. If you're using Connect, you connect. We have options for you. You just have to enable them. And during import, the right strategy that you've picked will be applied. So I think integration is really fast. Our docs are quite clear on this. Because it is an add-on, it is a additional price. But given that it's a relatively new product, we priced it very, very reasonably. So what is in it? Let's look under the hood a little bit. The way I like to describe it is there's two buckets of strategies under Data Prep. One is to optimize your CAD data. The other is to simplify. So optimize would be, adding intelligence to the file. Let's do some instance generation, go from a flat part to a more complicated assembly structure. Maybe recognize some features and add that information into the CAD file. Versus on the simplification side, removing bodies by size, removing features by type, removing any bodies that are not visible from the outside. So that's hidden body removal. So you can imagine you're reading a file, you set these options, however, and so out you get a file that is more tailored to your workflow that may be in virtual twin or robotics or simulation. And now the collision detection is faster or the visualization is better because the model that your application is actually dealing with is simplified, optimized for your workflow. And I've been talking about large model handling, but just a few use cases to illustrate here. With Data Prep, you can, like I said, improve the visualization performance of your application, up that FPS. But other use cases can be, maybe you want to protect IP, maybe the input that came in, not all of it should be in the output, or mask complexity. Let's say your robotics application, the designer created a very, very complex work cell, but all that your application wants to deal with is, okay, how do I visualize this, or I just want to do some collision detection for my planning. You don't need a lot of the details that is in the original design, and that's what we can help you do. Now, I know it went really fast there, so I wanted to break a little bit to see if we had any questions, and I also have a poll for you guys. Basically, I was curious to know, what is the most popular CAD format among our customers, users, and yeah, I was thinking it was going to be steps, so that's good to confirm. And how do you guys do data prep, or something like data prep today? And it seems perhaps the users are manually optimizing the models, or you've built some custom tools on top of other SDKs. So that's good to know. So yeah, that was sort of an introduction to the what and why, but in the next few slides, what I have are just some demo illustrations. What I've done is taken each strategy that I was talking about and taken an example of how it would fit into a customer workflow. The examples are very simple because I wanted to just show one strategy at a time, but you can imagine, combining these strategies into something more complex. So the first example I have is data prep being used in a simulation workflow, right? Simulation, or in our customer's application, we start with a CAD design, then there's some preparation that typically the user has to do. If they're savvy enough, they'll know that, okay, these small holes are not going to affect my simulation results, but they will affect my performance, so I should remove them. And then they have the final results. But given that, this is the typical workflow, why not add that as part of the import process itself? So as they're bringing in, you can show them a tick mark, hey, just remove anything that is smaller than some amount. So they don't even have to think about removing it after the file is imported. And that really simplifies the mesh and improves the performance of the simulation. Another example is in a digital twin workflow. So here we have a grinder machine model, right? If we imagine this application probably has a lot other such machines in the scene. And one strategy this application can build is prepare different levels of details of this input file and load the right level of detail depending on where the user is. So this output is sort of representing the LOD1, the most high fidelity model. And you can see FPS is already better by 70%. And then when the user moves away, perhaps they can load this lower LOD model that was also generated through data prep. And then finally the lowest. But like I said, these are very simple examples to give you ideas how this can be used in your applications. And then a final example I wanted to give was of a costing workflow. So one of the strategies, like I said, is instance generation. So given a flat part that has a lot of duplicates, for example, this one, there's a lot of duplicates in this file, but it's not really an assembly. And what data prep can do is identify the duplicates, create an assembly structure for you. So in this one, we went from 17 bodies to actually it's just 5 bodies once you instance them. And because downstream, it was all about calculating the cost of manufacturing these components, now you just have to do the calculation 5 times and multiply it and improve the performance. And then looking forward in terms of our roadmap, so this year in January, when we first launched data prep, we had the instance generation, filtering of small bodies, and removing of features available. It was a small, smallish release. We were trying to test the waters. looks like things are resonating. So we're continuing ahead with more features. In the short and midterm, we plan to release further improvements to instance generation. We have this idea of converting from graphical PMI, which is, visual PMI, to semantic PMI, which is machine readable PMI. So our customers, users don't have to do that stuff manually. And then in terms of simplification, one of the most popular features has been hidden body removal. So this is something I'll talk about in the next few slides, but that's definitely in the plans, and a few more things. And then looking, far out into the future, we have some ideas. We think maybe going workflow specific makes sense, but we want to hear from you. We want to work off of customer feedback. So please use this opportunity to let us know which direction would make sense for you, for us to take with the product. Okay, so hidden body removal. What is it basically? Given a CAD model, this algorithm figures out which bodies are not visible from the outside. Given this engine model, we figure out from the outside, from different views, what is really visible and what is not visible. And things that are not visible, we can remove. And so after import, what you get is just the outer bodies, the set of bodies that represents the outer set. So let's see. This one has, for example, 1,000 bodies. It's 200 megabytes file size. And the algorithm found out quite a few of the hidden bodies. So we can go ahead. Basically, only 57 bodies are visible, and that reduces the file size tremendously. So you can imagine the visualization performance of such a model in the application will be so much better than the original. And if all you were doing was collision detection or just visualization, you haven't lost any information while doing the simplification. So I think this is quite powerful. What we have out today is an alpha version. It was out in late July. So if you want to evaluate it, you can evaluate it right now. Because it's an alpha, you can imagine performance is something that we're still trying to optimize. It is something we're actually working on, but by GA, we think we can have something even better. So I recommend trying it out, giving us feedback, starting the integration, and going from there. Okay, so that was all I had for today for data prep. One common question that I get is about import performance. The question I get is, how will data prep affect my CAD import performance? And in the current form, I would say it will slow down the import performance a little bit because we are doing more. But what we also realized is we can optimize the way we're doing things because we know the strategies you want us to employ during the import, right? So for example, we know you want to remove hidden bodies. Well, rather than doing the full BREP import and then doing the calculations internally, we can use the visualization representation, do it in a faster way, and then just do the BREP import on the smaller set. So we think we can even improve the import performance with these strategies. It'll just take some time for us to implement them. But that's where we're headed.
We have a question.
Yes, tell me.
So there is also a simplify function in ACIS Modeler. Will this function to remove small holes and or hidden body become available through ACIS Modeler as well?
That simplify, I would say, is different. In fact, the hole removal that we're using in data prep is using ACIS defeaturing. So ACES defeaturing does have it, and that's what we're using today in data prep. Yeah, that's the answer. So not in the simplify function, it's a separate thing. Okay, and if there are no more questions, you know, we were a global team. I think you probably know a lot of the people that I'm showing here. So if you wanted, if you go back and you still have some questions, you can always reach out to us and we'll be there to help. And that's all I had for today. Thank you all for joining, and thank you for your attention.
Thank you very much.